So continuing through chapter 2, we're going into section 2.2, how to graph a function. So our objectives are pretty limited. Can I identify the graph of a function and extract some information from it? Okay. So the vertical line test. Suppose I have a sort of drawing in the plane. So here are my coordinate axes, my x-axis and my y-axis, and I have some sort of drawing of a graph. Okay, if every vertical line intersects at most one point, okay? So in the picture I drew, I'm not imagining it goes on forever. It's actually quite restricted. That's the complete graph. Notice that this vertical line doesn't intersect the picture at all. That's fine. This line intersects it once. That's fine, at most once. This line intersects once. And then over here, I start to get no intersections. But anytime I draw a vertical line that either doesn't intersect or intersects once, we would say that this graph passes the vertical line test. Okay. And if it passes the vertical line test, it's a function. So look at these two and ask, does it pass the vertical line test? If so, it's a function. They both pass the vertical line test. Any vertical line you draw is going to intersect it at most once, so it's a function. How about these? No, because it's possible to draw vertical lines that intersect twice, and that would be a problem. Okay. I'm going to utilize this blank space to sort of comment on the previous picture. So why is the vertical line test related to functions? What's the correspondence between these two things? Remember, a vertical line is something of the form x equals a number. So what's a function? 1x gives me 1y. Maybe it's not in the domain and I can't plug it in at all. That would correspond to so here, this x isn't in the domain. If I plug it in, I can't get anything out. But when I plug something in that is in the domain, how many things do I get out? One of them. If I were able to somehow plug in an x and have two corresponding y values, I wouldn't be a function. So this is why the vertical line test is related to being a function. If you can't plug an x in, that's fine, it's not in the domain. If you can, you should only get out one value of y. That's what it means to be a function. Okay, so let's continue on with this example. Can I obtain some information from this graph? For example, what's f of 0, what's f of pi over 4, what's f of 7 pi over 4, what's the domain, and what's the range? Okay, so try to ask these questions of yourself. Try to list out the intercepts as well. Then try to ask yourself, how many times does y equal minus 1 intersect the graph? For what values of x does f of x equal minus 2? And finally, for which values of x is f of x positive? So there's 7 different things here. We're going to run through all of these solutions. But go ahead and try to answer them yourself. I'll pause. Okay, so here's the graph. What's f of 0? Well, if I plug in 0, this tells me I get out 0. So f of 0 is 0. Similarly, if I plug in pi over 4, I get out 2. That tells me f of pi over 4 is 2. If I plug in 7 pi over 4, I get out minus 2. F of 7 pi over 4 is minus 2. Next, determine the domain. The domain is what can I plug in? And it seems to be that I can start at 0, including 0. I can go up to 2 pi, including 2 pi, and that's what I can plug in. So I'd say the domain is the interval from 0 to 2 pi, including them. In set notation, it's just all x's from 0 to 2 pi, including. Okay, what about the range? The range, remember, is all possible y coordinates. The highest I ever seem to get out is y equals 2. The lowest I ever seem to get out is y equals minus 2, but I do get out everything in between. Every other value of y I can draw, I can get out. So the range should be everything from -2 to 2, including. Intercepts. There are quite a few intercepts. If I set y equals 0, they're actually nicely labeled for us as x equals 0, pi over 2, pi, 3 pi over 2, and 2 pi. So those are the x-intercepts. Next, for which x is y equals minus 1? So if I draw the line y equals minus 1, it intersects the graph 4 times. So there are 4 values of x for which f of x equals minus 1. What about f of x equals minus 2? Well, those are actually labeled for us. The 2 x values that produce a value of y to be negative 2 are right here, corresponding to these points down there. The x values, by the way, that give me a value of minus 1, later on we'll be able to figure out what those are, because this graph is a particular function that we'll study, but for now we just know it happens 4 times. Where is f of x positive? So I'm looking for y values that are bigger than 0. Not this, yes this. So I do want this stretch of x's, but I don't want these, I do want these, and I don't want those. So that happens when x goes from 0 to pi over 2, but then also from pi to 3 pi over 2. And I'm not including the endpoints because I didn't want f of x to equal 0. I wanted it to be bigger than 0. Okay, so you can use interval notation or you can use inequality notation. That's fine. Okay. Another example, consider the function f of x. Find the domain. Check if a point is on the graph. If x is 2, what is f of x? What is the corresponding point on the graph? Reverse, if f of x is 4, what was the x value that got me there, and what point on the graph corresponds to it? And then what are the x-intercepts and corresponding points? So again, I'll pause while you do this. Okay, hopefully we actually did the work and we're not just, listening to this in the background. All right, let's find the domain. The only thing going on is the division by x plus 4, so I don't want that to be 0. And if I want x plus 4 to not be 0, I just want x to not be negative 4, so that's our domain. Every x except that one. The next question was, what happens when x is 1? So I plug in f of 1. Okay, let me get my old pen marks out of the way. If I plug in x is 1, I end up with f of 1 equals 4 over 5. So the point on the graph is 1, 4 over 5. Is the point 1, 3 over 4 on the graph? No, it isn't, because when I plugged in x equals 1, I only got out a single value of y, and it wasn't 3/4. So is the point 1, 3/4 on the graph? Nope. When you plug in 1, you don't get out 3/4. What if x equals 2? F of 2 is 5/6, so that point 2, 5/6 is on the graph. Moving on, if f of x equals 4, notice we don't know the value of x, we know the value of y. So x plus 3 over x plus 4 should equal 4, and now I need to solve for x. So I multiply both sides by x plus 4. That cancels this one, but introduces it over here. Distribute that 4, solve for x, and you'll get x is equal to negative 13 over 3. So if I wanted y to equal 4, or f of x to equal 4, there's only one choice of x that gets me there, and it's negative 13 over 3. So negative 13 over 3, 4 is on the graph. Next, find the x-intercepts. So I just set y equal to 0. And I do the same thing, multiply both sides by x plus 4, but then 0 times x plus 4, well, that's just going to be 0. Alternately, the way you can approach this is a fraction is 0 only when the numerator is 0. The denominator is irrelevant. If the numerator is 0, the fraction is 0. So x equals minus 3 is my only intercept. So that's the point, negative 3, 0 is the only x-intercept. Okay, last example. Find the average cost, the average cost function is given. So C of x, if x drones are manufactured per day, the average cost is 0.7x squared minus 45x plus 1,320.2 plus 10,000 over x. So determine the average cost of manufacturing 10 drones, 20 drones, 30 drones. Graph the function where x goes from 0 to 60, and if you're using a calculator, compute a table that starts at an x value of 1 and then increments by 1. Which value of x minimizes the average cost? You might be interested if you're running a business of minimizing your costs, so that could be an important problem. All right, I'll go back. Okay, Determine the average cost of 10, 20, 30 drones, graph the functions, create a table, and find the minimum. I'll pause while you do this. So hopefully we worked through and did what we could. If I let x be 10, I just have to plug it in. C of 10 is 0.7 times 10 squared minus 45 times 10 plus 1,320.2 plus 10,000 over 10, which simplifies down to $1,940.20. Similarly, if I let x equal 20, I just plug in x equals 20 and I compute 1,200.2. And if x is 30, I do the same computation but with x equals 30 and I get something a bit 933.3. Okay. Here's the graph. If we are not terribly clever about our graphing window, it might look kind of weird like this. This is a pretty poor graph, and if you drew a picture like this, I would have some serious problems with it. So before moving on, actually, I'm going to pause, try to find everything wrong with this graph. So here are some things I have. I don't know what this is. This is x equals what? This is x equals what? I don't know. Similarly, these aren't labeled. Are these increments of 1? I'm not sure. What happens here? Are those important values of x or not? What's the domain? Are there important values of x that haven't been shown? It's just not clear. Okay, but if we make a table, here are a bunch of values. Okay, here's f of 1, f of 2, f of 3, f of 4, and the calculator can just go ahead and compute. I think it wanted it to go all the way up to 60. But if you just look at this list, the smallest value happens right here at x equals 37. So 37 drones, past this point, it just keeps going up. So 37 drones is the minimum average cost. Average cost might be what you're interested in minimizing as a business. What are some other things you might be interested in minimizing or maximizing as a business? Probably your fundamental concern is to maximize profit. You might want to maximize revenue. You might want to minimize cost, but usually overall you want to maximize profit. Here we've minimized average cost per drone, which, maybe that's important. Okay, so that was section 2.2. It was much shorter than the previous section, so I just squeezed it all into one video.